so the question is, how do you actually create a package? We have this project and we have all these management tools that we can codify through talks. Let's do the formatting as well. So the dependencies here are black, and here we can do something a little fancier. So instead of just doing black dot dash dash check, we can provide some default arguments to it, which are going to be dash dash check dash dash diff dot. And what this will allow for is that, and sorry, I'm going to call this format. So this one installs black. It's going to run by default black dash dash check dash dash diff dot. So if we run tox-e format, it's going to create, again, a new virtual environment. It's going to install black. And it'll run that command. And notice that it says 2 files would be left unchanged. So it's only running the check. There's no diff because black already fixed our files. But what you can also do is pass different arguments to black using that positional arguments syntax that's here. So if I pass any positional arguments to tox, it will pass those to this command. So if I've run the check and I actually want it to format the files, I can pass a positional argument of just dot. So now it's just going to call black dot, and this will actually do the formatting. So by default, you can have it check the formatting, but you can also actually have it do the formatting with very little change. So this time, instead of 2 files would be left unchanged, 2 files in fact left unchanged when I tried to format them. So that's pretty cool. Yeah, so the question is, can you chain the sections with tox? You absolutely can. If I run tox-e, let's do Pi 310, which is the name of the default one because it's using Python 310. So the env list here corresponds to the name of the environment in that case. So it's similar to if I had something like this in one of the sections. You just don't have to do that for the default. So I'm going to run the Pi 310 environment, which will run the tests using PyTest, and then I'll also run MyPy with type check. So it's almost exactly the syntax that you guessed. Well, yeah, and you can also run these in parallel. So if you pass it a -p flag, it's running them both at the same time. Cool. Like I was saying, we have all these tools built into our configuration now, and we actually don't need, at the moment, like we don't need the requirements file anymore, right? Because now Tox is actually doing the virtual environment management for each of those activities. It's doing the dependency installation. So we really don't need our requirements file at all anymore. And if you run these, everything still works as you would expect. So that's cool. You finally have some confidence in your code, and you're ready to kind of share it. And like I said, you want to be able to publish the thing in a proper way so that people can install it with pip, for example. So now you start thinking about how to wrap this up into a package. This is the area I mentioned earlier. For those who were here, there's a lot of history, of course, behind how packaging got to where it is now. And in the last few years, there's been some effort to standardize and build a sort of new framework for building packages. The state of it is still something that confuses a lot of people, especially because there's a mass of legacy projects or projects that are maintained but haven't had an opportunity to update their configuration yet, that kind of show the old way of configuring and building packages. So the book goes into some of the nuance between these different configurations and why some might be better than others, or why some choose to do certain things. To cover how to build a good documentation. It's funny you ask that, because that is the chapter I just finished literally this morning, and it specifically uses Sphinx and goes through kind of how to build prose documentation and code, automated code documentation extracted from your code, and gets it all the way to publishing on Read the Docs. That's chapter 8. What I mean to say with all of this is that there's a few different files that are really important to packaging in general. And you've probably seen at least setup.py pretty often. And for a lot of newer projects, you've maybe seen pyproject.toml. There's also one in between that I feel like is kind of been silent a little bit. Not silent, but certainly hasn't received the same amount of attention as setup.py used to, and now pyproject.toml does. And it's a shame, I think. What this file is called setup.cfg. And what this file does is rather similar to pyproject.toml, in that it's not a file that executes code when you're packaging. So setup.py is a Python file. It runs when you install a package. Setup.cfg, on the other hand, is like pyproject.toml, where it's a static file. It provides metadata and configuration, but it doesn't do anything. It doesn't execute anything when you install a package. So that's a good safety feature, I guess, to not have to execute code at installation time. And for a wide majority of the projects out there, the part about executing code in setup.py isn't really necessary, because all you're doing is specifying like the name of the package, the version of the package, what the dependencies are, and that's, at a rough level, that's about all you need to specify. So setup.cfg is a good way of just supplying that static metadata and not kind of having to introduce a security hole. I don't know. It's a difficult sort of supply chain attack type thing that can happen with setup.py that people are worried about, which could be, a rare occurrence, but when it happens, it could be really bad. The trend is towards static metadata, which is still something they maintained with pyproject.toml. And everything is kind of moving toward supporting pyproject.toml for the most part. But there are still a few tools that don't, or that support it in kind of suboptimal ways. So Tox, for example, you can put your configuration for Tox into pyproject.toml, but you have to enter it as a multi-line string instead of actual toml. So you lose some of like the structured nature of it, because it's just one big string. The way the book works through this actually is to use setup.cfg, setup.py. It's there in the project built in the book as kind of a skeleton file for setup tools in particular to be happy. But then everything for the most part is kind of centralized in setup.cfg. And then there's a couple projects that only support pyproject.toml, like Black, that have that file around as well. So the project in the book actually has all three of these files, but it works through the reasoning for each of them. So do you use Twine for package publishing? Yes, is the short answer. So you can actually put a nice little environment in your Tox configuration for publishing the package, and it just calls Twine upload. basically. And I would still use that if I need to manually publish a package to the Python package index. But what I've been leaning toward, at least for open source projects, is the GitHub action for publishing, and that's provided by the Python packaging authority. So they're the same ones who manage the Python package index. So it's sort of semi-official in that way. The book goes through setting up all of what we just went through really as GitHub actions. And maybe a good time too to point out that the book has a code companion with it that has all of these different things mapped out. And I mean, this repository is open source. You can certainly check it out. There's no explanation, of course, for what's there, because they're really kind of the answers to the exercises in the book, if you will. You sort of can learn by example by looking at some of this, but the book, of course, has the explanations of why to do the things that are there. The next kind of step toward packaging this project, and I'm not going to go through all of the nuances of some of these decisions for the sake of time, but the first thing to do is kind of choose a package structure. And one that I've found particularly successful is to separate the source code and the tests into a source and a test directory. So we can make those now and move our Nimmer module into source and make a test directory and move our test module into that directory. And then we're going to create a setup.cfg. Again, this is a place where if you're familiar with setup.py, oh, thank you, not sharing. Sorry, so all I did here was move the Nimmer module into a source directory and the test Nimmer module into a test directory. Then I was opening a setup.cfg file. And again, this is where you would describe your static metadata for your package. So you start out and there's a metadata section, and you need things like a name and a version. Just go with 0.0.1 for now. Description, create acronyms from sentences. And you can give it a long description if you want, and you can read that from a file. So if you have a README for your project, it will read the contents of that, and you can tell it that the content type of that file is Markdown. I think it supports, like if you're using restructured text, you can do it that way as well. You can specify a URL. So if you have this on GitHub, that can go there. Maybe I'll upload this for real there at some point for you all. And the author, you can give it a license. There's a couple of other things you can add. There's like the Trove classifiers and things like that to tag it with the supported Python versions, and if it supports a framework like Django or something like that. But this is kind of what I would consider sort of the bare minimum for good metadata for a package. Would you be able to share today's code? Yeah, as I said, maybe I'll upload this as a repo, sort of one better than a gist, maybe. Unless people prefer gist, is there like interested in opinions on that, I guess. The next thing to kind of do is we can say maybe that this package requires greater than or equal to Python 3.10. And now, because we've moved the source code to the source directory, you kind of have to tell the package system where that lives. So there's a package dir. And the syntax is a little weird, also covered in the book. This package dir option is like a mapping. So the equivalent in Python is a dictionary, and it maps like empty string to source. So again, I'm not going to go too much into the nuances of that at the moment. And then in that package dir, you want it to find all the packages that are there. If you've seen this in setup.py before, I think it ends up calling find packages or something like that. There's an equivalent. So that just searches through the directory for packages. And then if you have dependencies, if you have runtime dependencies for your package, you can go through, you can add them with an install requires. So, if it depended on PyTest, could put it here. We don't have any dependencies at the moment. Finally, need to do options, packages, find. So that corresponds to this thing. So we want to look in the source directory. Not sure if it's really necessary, but I sometimes do this just for good measure. Like, we don't want to include any of the tests in the package that we publish unless you want people who install your package to run the tests. Otherwise, it's sort of wasted data. This might work. This is a sort of minimal configuration for a package in setup.cfg. I'm also going to create a PyProject toml file, and we're going to use some of the newer Python build framework to build this package. So in here, there's a build system section, and this sort of requires setup tools we're going to use to build the package and wheel, so that we can build a wheel of the package. And the build backend is going to be setuptools.build meta. So this is all basically saying we're going to use setup tools to build this package instead of some other thing like Poetry or Flit or something. This is what it requires to do that. Finally, I think, like I mentioned earlier, setup.py just needs to be there for setup tools to be happy. You do need to do sort of the bare minimum here. So from setup tools, import setup and setup. So then, instead of the old way you might have seen for building packages, which looks something like that, you're going to use this newer tool from the Python Packaging Authority called build, simply enough. So that's here. So build kind of tries to standardize on a lot of the process for building a package, and is associated specifically with PEP 517, which again kind of introduces this new framework of building packages. So there's this idea of a build front end and a build back end. So they've separated like the activity of actually the logistics of building the package from what the user sees while they're building the package. So there's an opportunity to create tools with better UI for building and so on. So that's one of the coolest new tools out of this that I have found. I've installed that through Pipex, this guy here, Pipex install build. That exposes this PyProject build command. You can just specify the directory that it should build as a package. If we're lucky, this might work. So it also knows about creating isolated virtual environments for the purposes of building. And remember that in pyproject.toml, we told it that the build process needs setup tools and wheel. So you can see here, it's installing those into this environment. It says getting dependencies for source distribution. I think that is installing the dependencies from the install requires field, which we left off for the moment, if any, but here we go. Yeah, so now you can see that it went through and built a manifest of all the different sources needed in the built package. Yeah, so it says like standard file not found. I didn't actually create a README, but I mentioned it in the setup.cfg file. It also warns that if you supply the author field, author email should also be supplied. That's fine. And then creates the package, and then you can see it's building a wheel from the source distribution. So this is a pure Python package, but this process will support creating files with Cython, for example. So you can do kind of the pre-compile step to get non-Python extensions built as well, and ultimately produces a tar file of all the source code and a wheel file. Again, you can see it says Py3, so it's a pure Python binary wheel. We have a package.